Hi everyone and welcome. In the previous video, we have covered that how we can connect the DHT11 sensor to this XIAO ESP32C3 board and publish the temperature and humidity data over Modbus TCP protocol, and how we can read the temperature and humidity data in the Modbus TCP client. Okay, so basically we have covered this topic, that how to publish DHT11 sensor data from XIAO ESP32C3 board to built-in Modbus TCP server, and we were reading that data in Modbus TCP client. So basically, ESP32C3 act as a Modbus TCP server which serves the data of DHT11 sensor. Now in this video, instead of DHT11 sensor, we are going to read the data from analog device. Okay, so here you can see I have connected the potentiometer, okay, which I can slide like this, and I want to read the data. Okay, I want to publish the data of this potentiometer to my Modbus TCP server, which I will create inside this XIAO ESP32C3 board, and I will use Modscan software to connect with this Modbus TCP device and will read the data here. Okay, I can use some other Modbus client software as well, like Node-RED. Also, I can use another Arduino board or another ESP32 board to act as a Modbus TCP client, and I can read the data. And I can use some SCADA software. I can use Excel to read the Modbus data. So everything is possible, okay, once you have your Modbus TCP device with the data. So in this video, we will cover this topic, that how we can publish the analog data from XIAO ESP32C3 board to built-in Modbus TCP server, and how we can read the data in any Modbus TCP client. So if you have the data in your Modbus TCP client like Modscan 32, then you have the data in your any Modbus TCP client. Okay, so first of all, we have to learn the sketch. We have to learn the code, and then we have to upload the code in the XIAO ESP32C3 board, and then we will slide our potentiometer, and we will have a data on the holding register 40,001. Okay, if you create the basic Modbus TCP server with the XIAO ESP32C3 board, then there is no use of that Modbus TCP server, because it is not serving any data. Okay, and then after we have learned that how to connect DHT11 sensor with ESP32C3 board, and then after ESP32C3 board is creating itself as a Modbus TCP device, or you can say Modbus TCP server, and it is serving the data of DHT11 sensor. Now, in some cases, we have some temperature sensor. You can search on the Google some analog temperature sensor which can attach with the XIAO ESP32C3 board. So if you have those kind of sensor, and if you want to publish those sensor data, okay, you can map the sensor data, you can map the temperature, analog temperature sensor data, and you can publish it to Modbus TCP server. That is possible. Okay, so you can read it wirelessly from anywhere in your plant. So that is one of the application of this. Okay, so that is possible. So let's see the code, and let's see the demo. So first of all, you have to install this library. So in the library manager, you have to search for Modbus -ESP8266, and you can see it is already installed. Once you install it, you can use this code. So here you have to provide the SSID and password of your Wi-Fi, okay, in which your ESP32C3 is going to connect to. Okay, once you have provided it, you have to attach the analog sensor. Okay, I have attached this potentiometer to A0. Okay, this is the A0, the first pin, and the black one is the, which one, black one? Yeah, black one is the ground, and the white one is the 3.3 volt. Okay, so it will read the data of this potentiometer, and then it will publish the data on Modbus TCP server. And you can see here MB dot holding register analog register address. Okay, and it will publish the sensor value. I can also map the sensor value if I have some requirement, but if I want to upload the row value, then I can also upload the row value. Okay, and analog register address, you can see 0, so it will be available on 40,001. Okay, so let's see, and let's upload the code. So COM4 serial port XIAO ESP32C3. Okay, and we will upload it. And yeah, here you can see in the MB server we haven't provided any port number. So the default port is 502 for our Modbus TCP server, which we are going to create inside the ESP32C3. Okay, so it's a done uploading. I can open serial monitor and I can have the IP address of my Modbus TCP server running inside this ESP32C3. I can open command prompt. I can ping 192.168.1.5. You can see I am getting the proper ping. Now I can go to Modscan 32 connection. Here is the IP address and here is the default port number, and I can press OK. You can see it's a full value. It look like it's a linear port meter, but it's not linear. Okay, so if I extend it up to this, then also you will see the full value. If I go beyond it, you will see the value is decreasing, right? I can map the values in any SCADA software or any other Modbus TCP client, but this is a basic Modbus TCP client, so there is no map options. Okay, and it will go to 0 now. Okay, 29.0. If I want to increase, then I can increase like this. So if you have some temperature sensor, then you can attach the temperature sensor on the analog pin of ESP32C3. You can read the temperature sensor data, you can map your temperature sensor data, and you can publish your temperature sensor data on the Modbus TCP server. Okay, now if you want to map your data, okay, so if I want to map my data, then what I have to do is I have to copy paste this, and here I have to use the map value. Okay, we'll save it and we will upload it. So 0 to 4095 is converting to 0 to 100. Okay, so right now you can see 4095. So it will, whenever it will reach to 4095, it will convert it to 100. What happened? Let me again upload. Whenever you upload the code, the Modbus TCP server is closed. It is not running inside the ESP32C3. So that is why you will see the warning here. Now, if I open the serial monitor here, okay, Wi-Fi is connected. The IP address is 192.168.1.5. I can connect again and you can see the value is 100. Okay, previously for the full scale the value was 4095. Now for the full scale the value is 100. We have mapped the 4090 to 4095 to 0 to 100. So let me scale it, let me change the values. Okay, you can see it started decreasing. Okay, and it is 0. If I want to increase, then I can increase like this. Okay, so if you have some temperature sensor or other sensor and if you want to connect to this XIAO ESP32C3, then you can connect and you can have the data like this. So you can create your own product like temperature sensor with Modbus TCP output, wireless Modbus TCP output. Okay, so that is possible. So I hope this thing is clear. I will create a blog for this. I will upload the code on the blog. Also, I will upload the connection diagram on the blog, and you will have your blog link beside this. Okay, and you will have the video watch link here. So if you have any question or any concern regarding this, then you can always ping me on WhatsApp, Telegram, Instagram, anywhere. And as long as your ESP32C3 device is up and running or it is connected to power, there you can read the data in your Modbus TCP client. Okay, so I hope everything is clear, and if you still have any question, then you know where to ask. So we will meet you in the next video. Till then, take care, goodbye, and thank you.